So today we're going to be simplifying radicals, and there's different names for the things that we see on here, so just write it down. This thing you see here is called a radical. So from now on, when I talk about radicals, that's what I'm talking about. I'm talking about it's a square root. Okay? Anything inside, so this letter, whatever's inside, is called a radicand. Radicand. And then if there's a number in the front, that's called a coefficient. Just like what we've been doing, that's a coefficient. Okay, because that's the number in the front by itself. The coefficient of the radical. So for instance, number 3 has a coefficient of 6. Number 1 has a coefficient of 1. It's an invisible 1. And then it's a square root of 16. The 16 is the radicand, and then the 81 here would be the radicand. So if you look, I gave everybody multiplication charts. Everybody has their multiplication charts that look like this. All of the diagonal numbers, so all of these yellow ones that I have here, the diagonals, those are perfect squares. Those are called perfect squares. So right here where it says list the first 12 perfect squares, you would go down this list. 1, 4, 9, 16, 25, all the way to 12, right? The first 12. So from here, this is the last one. Here. So we're going to write all of these down because those are perfect squares. So go ahead and start writing them. 1, 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25. That's why they're called perfect squares, because they're multiplied by the same number. 6 times 6 is 36. I'm getting the numbers from here. 1, 4, 9, 16, 25, 36, 49 is next, because 7 times 7 is 49. 8 times 8 is 64. 9 times 9, 81. 10 times 10 is 100. 11 times 11 is 121. And 12 times 12 is 144. Okay? So if we take square roots, like this one, number 1 said take the square root of 16, that means I'm looking for 16 here. And what is, it would be 4, right? The square root of 16 is 4. Because 4 times 4 is 16. So over here, I would put the square root of 16 equals 4. Okay? What's the square root of 121? Look at your multiplication chart. 121 is right here, and it would be 11, right? 11 times 11 is 121. There's a 6 on the outside, so keep that there, 6, right? What's the square root of 81? Go look for the square root of 81. 9, right? So the square root of 81 is 9, but there was already a 6 on the outside, so you multiply them. Okay, so what's 6 times 9? Use the calculator. Or use your multiplication chart. Look at 6 times 9. 6 times 9 is 54. Oops, wrong page. What about the square root of 100? What's the square root of 100? 10, right? But there was already a 3 on the outside, so it's 3 times 10, which equals 30. Okay, any questions? Those are easy because they're perfect squares. 16 was a perfect square, 81 was a perfect square, 121 was a perfect square, and 100 was a perfect square. But what if they're not perfect squares? Right? What happens when they're not perfect squares? Like 32 is not a perfect square. If you look at your multiplication chart, look, it's 36, not 32. So then what do? You have to do the factor tree. So we're going to go back to middle school when we would do factor trees. What times what gives you 32? Give me two numbers that multiply and give you 32. So let's go look for 32. 8 times 4, right? So I'm going to say 8 times 4. Is 4 a perfect square? Yes, it's 2 times 2, right? 2 times 2. Circle them. What about 8? What two numbers multiply and give you 8? 4 times 2. 4 times 2 gives you 8. Well, we're going to start circling things that cannot be reduced anymore. Like 2 cannot be reduced anymore. So let's write down some numbers. I want you to write down the number 2. That's a prime number. It cannot be reduced anymore. 3. If you get to a 3, you circle it because it cannot be reduced anymore. 5, 7, 11, 13, 17, what else cannot be reduced anymore? 19. Can 19 be reduced? 19 is a prime number. 23 is a prime number. And not 24, not 25, not 26, not 27, not 28. I think we're going to stop there. So if you get any of these numbers, you are done reducing. So you see this 4? I'm not done. Because 4 is 2 times 2. Okay, so you're going to do the tree until you get all the prime numbers. That's called a prime factorization tree. We did it in middle school. Once you get all the numbers, this is 1, 2, 3, 4, 5 of them. You're going to put them under here. So the pairs are going to come out as 1. So this one's going to come out as 1. And this one's going to come out as 1. This pair comes out as 1, 2. And this pair comes out as another 2. Whatever doesn't have a pair stays inside. Okay? Think of a club. The single people go inside the club. The couples stay outside the club. They don't go in the club, right? So any couple that we have, 1, 2, come outside, 1, 2. Any non-pairs that we have stay inside. So then the outside ones, you multiply them. That's 4, square root of 2, and we're done. Pause the video. We're going to do 3 more examples. Okay, look for 180 in the multiplication chart. 180. Where is 180? Yeah, I see it right here. Right? That's 10 times 18. So I'm going to say right here, 10 times 18 gives me 180. But these two numbers are not prime numbers. So I have to keep going. Keep going. So what two numbers multiply and give you 10? 2 and 5. 2 times 5 gives you 10. 2 is a prime number, so I circle it. 5 is a prime number, so I circle it. What about 18? What two numbers, ¿qué números te multiplican y te dan 18? What two numbers multiply and give you 18? 6 and 3. 6 times 3. 3 is a prime number, so I circle it. But 6 is not a prime number. You see, 6 is not up here. So I have to keep dividing the 6. 2 times 3, right? 2 times 3, and they're both prime numbers. Only circle the prime numbers. These are your prime numbers. Okay? Prime numbers. 2, 3, 5, 7, 11, blah, blah, blah. So now I have, under the radical, I have 2, 2, 3, 3, and 5. 2 times 2 times 3 times 3 times 5. Those are my prime numbers. And when I multiply them, all of those gives me 180. Take out the pairs. The couples need to come out of the club. They don't stay in the club. So this is a pair. Los pares se salen. So this is a pair of 2. This is a pair. It comes out as 3. Is this a pair? So this one stays inside the club, inside the radical. Okay, so I have 2 times 3, 6, square root of 5, done. That's the answer. Okay, I want you to pause the video and I want you to try number 7. Try number 7 by yourself real quick. Pause the video. Okay, so you will quickly realize that 147 is not in my multiplication table. I cannot find 147. So if you cannot find it, that doesn't mean you cannot reduce it. That just means you're going to have to be using the calculator to divide. So I need to divide 147 by my prime numbers. Can it be divided by 2? Can it be divided by 3? Can it be divided by 5? So use the prime numbers to find the factors. So I'm going to use my calculator, and I'm going to start dividing 147 by 2. That doesn't work. 147 by 3. That works. So I can do 3 times 49 as my numbers on here. 3 times 49. 3 is a prime number. Continue. 7 times 7.